Hello again, my name's Derek Bailey and I've been a woodturner now for over 40 years and taught for the last 8, all those days have gone. This is part 2 of my video on the sharpening jig. This time I'm concentrating on sharpening the bowl and spindle gougers, parting tools and scrapers etc. that normally requires an acquired skill. So I hope my little accessory helps to overcome that problem. Now please wear face goggles, as the sparks can change direction depending on where you place the tools on the revolving disc. Ideally, the jig is suitable for the more experienced of you who wish to use more advanced turning tools. The aluminium oxide discs are not suitable for grinding carbide tip tools unless you exchange them for a diamond disc. I recommend you get a thin loop system, hook and loop system for your abrasives discs, as you will need to change them from time to time to get a finer cutting edge. Usually grits from about 80, 100 down to 240 for a fine edge. Well, I hope you can get the cutting edge you want with this jig. Anyway, enough waffling, let's get on. Here I've got a very hard piece of timber cut off from some timber I've had for years and never really been able to decide what it was. But beech or oak would be ample for this job. The tool isn't running across the tool rest very well, so I've put a bit of wax on it to make it easy for myself. I think I've become obsessed with the indexing jig. I could have saved myself a load of time and setting up procedure if I'd have just drilled the 4 holes while the wood was still in the square and then turned it to the finished diameter. So I'll skip the 5-minute video showing me drilling the holes using the indexing jig and jump straight to the finished item with the 4 holes already drilled. Again, the mystery timber, which is 50mm square by 100mm long. I'm going to drill the hole and then make a 45-degree bottom to it so that any size turning tool will be automatically centered when the clamp screw is operated. In order to connect the clamp to the clamp guide, I'm drilling a hole for a 6mm diameter bolt. Using my bandsaw, I've made a slot in the centre third of the tool clamp in order to accommodate the tool clamp guide. Back to my mystery timber again, 35mm square by 125mm long, to make the tool clamp guide. It's great to have a bandsaw instead of hand sawing these joints. It speeds things up no end. I'm now making a tenon to suit the tool clamp slot. I've left the centre dimple in the end of the guide so that I can mount it between centres and turn it to a cylinder. I'm measuring the clamp support holes ready for the clamp guide stem to be turned down to the diameter to suit these holes. Using two opposing jaws of the chuck, I'm gripping the tenon of the clamp guide so that I can turn the stem ready for insertion into the three holes of the clamp support. The standard procedure when making a precision fit like this is to just turn a portion about 3 or 4mm long for the diameter that you want, continuing that through the rest of the length. Once I've got a tight fit, I finish off with some 120 grit abrasives just to finish it off to the correct size. As you can see, the tenon and the slot fit together okay, and now we have what is generally termed a knuckle joint. The slot in the tool clamp was quite strong, and even though I put a bolt in, I couldn't tighten it up, and the two items kept moving. So I've just put a relief, removed some wood in the corners of the slot, which helps it to bend a little bit, and the result was that it clamped together perfectly after that. When you're making a rod like this, it's essential that you move your body and not your arms in doing this, and your body will generate the straightness of the rod, especially when you keep your fingers against the tool rest as you move along. And then it's just a simple matter of using the full width of the abrasive to flatten out any slight undulations. Seeing the rod is going to get a lot of wear over time, I've coated it with sanding seal and two coats of melamine. The melamine goes pretty hard over time, and so hopefully will resist a bit of wearing for the duration. I've just made two rod brackets out of cheap scrap wood pine. It'll be suitable for what I want to do. I've returned to the tool clamp, and I've put a V in the bottom of the hole, and I'm now going to insert a 6mm threaded insert into the top for the clamp knob. I'm just measuring the base diameter of the threaded insert because I've often shown that you've just to allow a little bit extra to the measured diameter, because if it's a tight fit, the metal splits and you can hardly get the flipping things out. It is slightly tapered, so you measure the largest diameter under the thread portion and just allow a little bit extra on top of that for sizing the drill. Now put a nut on the end of the threaded bolt, and I'm going to put what we call a T-nut, and then lock the two together, the nut and the T-nut together on the threaded bolt, and that will give me a clamp area which should span the width of the turning tools. Just make sure you saw off the 4 little sharp spikes on the underside of the T-nut before you assemble it properly. As you can see, the top of the T-nut bridges both sides of the flute of the turning tool and clamps nicely at the bottom of the V-groove. As you can see, I've made a nice little star knob and super glued it to the head of the bolt, the 6mm bolt. If you're unfamiliar of making star knobs, there's some nice little videos on YouTube that show you a quick way of doing them and actually making a jig if you're going to do a lot of them for future projects. I'll see if I can put a link in the description. I've put some 5mm threaded inserts into the side of the sanding disc frame for the guide rod system to be screwed to. I'm just making sure that the height of the guide rod is consistent throughout the width of the sanding frame. I'm just testing the angles of movement of the tool grinding jig to see what parts of the sanding disc it occupies as it moves, and because it's quite a complex movement when you look at the knuckle joint, etc., that generates the shape of the bevel on the turning tools. So because it's quite a clunky tool clamp, there may be occasions when it touches the sanding disc instead of the tool. So I'm going to keep checking it to see what ranges of bevels can be achieved, and how much I have to alter the shape of the tool clamp itself so that it doesn't rub on the sanding disc. I'm just testing how easy it is to remove the disc sanding table and go to the grinding jig itself. It can be a little improved. I'm sure one of you, or quite a few of you, might think of a better idea, a quicker idea to remove the table and go to the tool grinding jig. There's no such thing as a perfect jig, so I'm open to any ideas that can improve its efficiency. Here I'm using the upward rotation of the sanding disc, and it'd be interesting to see the advantages or disadvantages of using different sides of the disc. I noticed at a later stage when I use the sanding table and I'm grinding screw chisels, it's better to be on the downward side of the disc rather than the upward side, because it may skid across. Anyway, you'll see that later on in the video. The nut and the T-nut combination on the tool clamping bolt is a little bit too long, and it's not withdrawing upwards to allow the larger turning tools to go in. So what I'm doing is I'm going to make a recess where the threaded insert is into the top of the tool clamp. You'll see that as I do it, and it gives me more room to get larger turning tools in. I'm just measuring the distance over the nut corners to see what diameter drill that I need so that the nut goes into the hole. When you go into a larger size twist drill, it can be quite grabby, so the pressure needs to be very light and let the drill spin, and then gently press forward so that you can dictate the depth of the hole. I have on occasions pressed too hard, and the coarse fluting of the drill used to drag my drill right into the wood and make a right mess. I now need to reduce the length of the bolt, as the top of the clamping knob interferes with the sanding disc when I'm doing some of the turning tools. Now I've made this slight modification to the tool clamp, I can accommodate most of the size of tools that I'm going to use. To finish, I've rounded some of the edges to give a little bit more freedom for the position of the clamp against the sanding disc. In order to set up the jig, I'm using Henry Taylor's profile sets, which gives us different shapes for use on ball gouges and spindle gouges. Now, if you notice in the diagram, I've tried to indicate the shape looking on the edge, on the side of the downward slope. If it's straight, it'll cut okay, which is indicated in grey. If it's blue, i.e. it's got a convex surface, that's the best surface you can get for cutting. And please avoid the red line, which is a convex surface on the edge, which won't cut very well, if at all. With these profiles, there are 6 types of bevel shapes, and I've put tapes on them and given the degrees of which they're ground, and that will be reproduced on the grinding jig. In this part of the video, as I'm moving the profile sets around, just take a look at the edges, and I hope that'll become clearer to what I tried to show in the diagram. There are 3 designations: the letter for the clamp support holes, the angle of the clamp, and the projection of the turning tool in front of the clamp. Once you've achieved the correct angle on the angled clamp, which is roughly about 60 degrees, which is on the chart above, stick at that. Don't start changing the clamping angle. What you do is you move or adjust the tool projection and the clamp support hole designations in order to achieve the different profiles on the Henry Taylor samples. Once I'd achieved the correct angle of the angled clamp, which I mentioned earlier was roughly 60 degrees, I made a mark on the side of the angled clamp itself, so that if I did knock it or adjust it, I could get a close recreation of what I'd achieved. Here I'm illustrating how I achieved the figures in the data sheets. What I did, I rotated the disc by hand and scratched the Henry Taylor samples until I got a scratch the full depth of the bevel. Then I recorded the projection of the tool and the hole in the clamp support that I was using. It didn't matter what sample I started with. Once I'd set the clamp angle, then I kept it at that throughout the full range of the sets. In order to turn the sanding table into an accessory so that I can grind things like screw chisels and spindle roughing gouges, parting tools, etc., I need a platform to do it on. The sanding disc table is too long and interferes with the handles on the turning tools, so what I've done is I've made a subframe, or a sub table if you like, which is higher than the thickness of the handles, so that I can grind the tools I've just mentioned, for example the parting tools, etc. I'm putting M5 threaded inserts into the main table and drilling through clearance holes in the sub table for countersunk M5 bolts, which will be tightened up using an Allen key. Once I'd established the correct angles using the table for the various tools like the spindle roughing gouge and the parting tool, I'd indicate that with a line and a reference note on the side of the frame, so that you could create a repeatability to maintain the edges of each tool without having to keep glancing across the edge to see if you've lined it up with the sanding disc. You could just go to the lines that you've made and the recording of those lines against the tool that you're going to grind. Because I was so focused on the camera angle, I forgot to clamp the jig base to a bench, and you'd have seen a slight movement as I was grinding, which isn't very helpful.